Alright guys, so where we ended up last time was we generated two things here. The first one, this bottom one shall I say, is a pre-deck of zeros and ones, and this can be seen right here. So this deck is the complete deck we did in the old method, which is brute force. Now we're trying to do it again in this method, which should be much easier to work with. So here's our first deck. Now we just need to add all the possibilities, all the missing zeros need to be put in as a possible 1, right? Because those are all the missing 1 number possibilities. So to do that, now that I'm seeing this, I'm actually thinking of a new thing. My idea was to do the same thing we did here once for each number we have in here, which basically requires us to redo this entire math process, which is very annoying, and obviously nobody really wants to do that. The alternative perhaps could be simply by taking in this loop, this array, and condensing it further and further to replace a single point in it. So what do I mean by that? What I mean is that we take this initial array and then we just replace the missing zeros. I just realized if we do that, we might actually run into another problem. Okay, so I'm not going to do that for simplicity. The reason is that once we have two random numbers, we can do them simultaneously instead of having to do this over and over again for an endless amount of time. Alright, so I'm going to do this another way again. So what I'm going to do is take in a for loop, which is going to take in this system, and we shall take in this array. Now I believe we should first have the array indexed. This should not be indexed. What we shall do is now create a for loop which will simply do what was done here. Am I right or am I wrong to think that? Here's what I'm thinking. If we just take this exactly as is, copy, paste, inserting this number into it, one by one, while this here shall be replaced with a normal tunnel from the original array. This should be a normal tunnel. Now it will go in here as a normal thing, change it, come back out as a super enhanced array, which would actually mean that I don't need this for loop. And this is a 3 system array. I'm not sure if this is gonna work, guys. I'm very skeptical right now. Let me see. Let's run this once. So, running it once, everything is failing, including our initial array. So, initial array comes in, we add to it this number, which is definitely none of these numbers. This number comes out here. Alright, so me thinking about this logically, I do not see anything wrong with the logic I have just implemented. It seems that the computer does not like what I just did, because now array 5 is not working. Why is this not working? It was just working. Probably because I flipped this and did this as minus x times 100, and this needs to become an addition palette. An addition. There we go. And let me replace this with an addition as well. This could be the mistake right there. There we go. Perfect. So the first one has 1. Second, third, fourth. You can see how this number 1 keeps jumping between them, going through all the possible 1 iterations. These are all the empty ones that could still be filled with a single one. We go up to 45 and then we start over. So going back to 0. Our specific case had number 114, which was here. What was that? Number 30 perhaps? 31, 32, 33. Case 33 is our missing number. So it's already there, right? We just need to extract it. So now we have all these possibilities right here. Instead of this and this one is no longer necessary, because right now I have it all right here. I would really like to be able to have this system run from here somehow, because we're doing this exact same procedure twice. So it would be nice if I could do it twice from the beginning. So basically we would need to, well, I don't think there's a way to do it. Alright, I'm gonna go ahead and condense this and get back to you guys. Alright, so there we go. This creates decks of zeros and ones for analysis right here. And this does it based on what we have initially, plus all the added variations from here. Now, this added variations is with a single missing card. There is cases where we might need more than a single missing card. So this will need to be actually altered to create multiples. And I think if we can have that implemented in here, again, that would further enhance the speed of the system. So I know that might not make much sense. So now we took this initial system, we went ahead and we got these 6 numbers from the original 7. We came in here, we created this array with all the pre-ones, and then we finally got here and added to this last one the missing numbers. So now we have an array which in every single instance has 7 cards, where one of those 7 cards, where 6 of those 7 cards are the cards we know, and one of them is the one that's varying. And this system can now be sent for analysis. So there we go. Create decks of zeros and ones for analysis. Eliminate cards from deck. Reshape deck to 1 dimension. This is still a single deck, right? Create standard 4x13 52 deck of cards. Create pre-deck of zeros and ones depending on here. So here we can have, for the pre-deck, in essence, is, in this case we took 6, but we could only have 2. We can have 2, we can have 5, we can have 6, and we can have 7. We can have 0, but then that would pretty much have to go through every single iteration of poker, which is, I'm just not going to do that. Not with brute force. We can do normal math for that. So this is just predicting the last step of the river. Now, what if I want to figure out the turn? Let's say we're not at the river, we are at the turn. At the turn, we need to create an entirely new system. And this system will need to be implemented back here between these two, if it is the turn or not. So this is 1 card. We're going to have a switchboard perhaps that picks, okay, which step are you on? Create possibilities, process possibilities. So this creates possibilities. This pre, this is post basically. In between, this is with 1 number. We might have to do this with multiple numbers. That's simply it. So this is doing a number per time, right? Let me create an indicator of this. So what's happening here is that when we run this, we're doing 1 number every time. I would like this to be enhanced so that we do, sometimes we might need to do 2 numbers at a time. So let's get into working on that. So I'm gonna see what we did here. Well, actually I don't care what we did there. We're gonna run a for loop. We're gonna need 2 for loops. We're definitely going to need 2 for loops for this. What we do is the first for loop, there we go, and the second for loop, there we go. Now the second for loop, I'd like it to be on the inside. There we go. So what's happening is these two need to be put into an array together unless they are equal to each other. If they are equal to each other, we need to ignore them. So if this is equal to this, we need to ignore it. We'll come back to that in a second. Otherwise, what we would do is we would take these, put them together as a single array, and output this array here. Now, once outputted, this array will need to check a true or false box based on whether these are the same or not. Oh, I see. This will be done every single time, which means the true or false box will need to be in here. So now our true or false box will be in here and will dictate whether this will output or not. So if they are equal to each other, nothing happens. If they are not equal, then I'd like to insert it into a blank array. New element into a blank array, which will need to update every step. Therefore, obviously, in the true case, nothing happens. In the false case, it goes through. This is our main processing step, which basically implies that this is the main processing step, which basically means that there's nothing out here that could affect this. So we can just take this, do it as a shift register, in, out, there we go. Now, what is this? I can do this as probably a constant. It's just going to look like that, so I don't want to do it as a constant. What I would prefer to do is to create a system similar to this, but we need to have a third dimension of unknown size. Let me do a constant for now, just to see whether it will decide to work or not. And let us go ahead and investigate whether this worked or not. First off, it's still a 1D array, so that's first thing is wrong. This should not be a 1D array. This is wrong. This should be basically not add both numbers. It should work in a different way. Basically, what we're doing is we're gonna have to rebuild an array, maybe. Yes. This appears to be what needs to be done. Create an indicator. There we go. Now, if this is right, we should only get 2 of these filled and everything goes straight. Yes. Beautiful. So, we just went from 414 with all others except 414 all the way down till we process them all. Oh, not this way, this way. Till we process all the 414s. Then we start with the next number on our list, in this case 413, and 413 does not include itself, obviously. That is perfect. That is exactly what we needed. Create a constant out here, and I will go ahead and eliminate the index items there. I think I might be able to condense this. No, that's fine. Alright, so let me go ahead and condense this and get back to you guys. Alright guys, so here we are. Now, while I was doing this, I started thinking of something, and what I started thinking of is if I can set up this system to input into this system directly. To do that, I would need to add a second level of array here. So what I'm going to do is I'm going to save this, and I'm going to resave it. Let's see. Original will be closed, copy will be in memory. Okay. I'm going to call it poker 12. There we go. And just to make sure, I want to make sure poker 11 is still there. Yes, perfect. So what we're going to do is try to fix this. And the way to do this would be, it's not hard, it's pretty simple. I'm going to first try to do it for this system and then try to implement it here. So I'm going to just copy, paste this up here. This will use the same input from there, but we'll have a different input here. What will end up happening is that this here will be in a for loop where this part will be self-updating. There we go. From this point to create all the new possibilities, which hopefully will work. Let's go ahead and check. Run. So there we go. We have 1, 1. Now when I run this, it should flip through all the single ones. As you see, this one is stable throughout this entire thing. Now, aha! First error. It did 1, 1 again because it assumes that we never did this before, and then switches them through. So we need to eliminate this one thing, but otherwise we are fine. So let me add a note. Eliminate repetition. I'll come back to that. Now the other thing I want to test is what would happen if I build an array out of this and input that into, oh no, into this system. Would that affect it in any way? Basically, I want this to be identical. So array 6 and array 7, I want these two to be identical at all times. So yeah, that did not work. That did not work at all. Why did this not work? Because it appears that the indexing is working the wrong way around, or concatenate inputs, disable indexing. No, that would not work because this and this are now that is not working. What if we have the same number twice? How about that? Now this will do double the work, but it might work. No, we got an error. That doesn't work. This doesn't work. Does this mean that we're gonna have to do this every single time? Because I don't want to do that. Unless we can easily reshape No, we can't reshape it to be a 2D array. But perhaps what we could do is to basically can I reshape it into a 2D array? I know I just said that, but I'm curious. Can I reshape it in a way so that there is just an extra single dimension doing nothing, basically? Or is it going to fill it up? There we go. That seemingly worked. Except we might need to reverse the polarities, that's all. Yes, we need to reverse them. So let's do that and give it a shot. So if this is the size and this one connects here, this could in theory connect up there, process it, we have liftoff. It seems to work. 8, 9, 10, 8, 9, 10, perfect, beautiful system. So there we go, we have just accomplished something. Let me go ahead and explain what I just did and why this is actually very good. First, now we have 6 and 7 the same, which means now we can have input coming in through here or through here with no problem whatsoever. They will be processed and you will get the output out of them. That is exactly what we need. The beauty of that is that now I no longer have to worry about multiple processing systems. So basically, if not for this step, then I need to have this one for this and then this one for that. And I don't want to do that. I would like to have them all basically built into a single, I'm not sure what to call this, a formula node or a block or a system, or in theory it's a sub VI. In a perfect world, since this here is very highly based on what's going on here, I would also like to have this built into the entire thing, but that's just not gonna happen this time. Let me go ahead and finish basically arranging this, and then I can probably figure out how that would work. We'll have a clearer view of where we are and what we have, and then from there we can continue to see how we can improve. I'll get back to you guys in a second. Alright, so here we are, guys. I put this into a little thing by itself and create 2 card combos right here, and then this will do the analysis. Now we just need to create a switch. So basically we're going to need a switch to figure out whether we're doing the river. So this here is in charge of the river, while this here is in charge of the turn, and then we're going to have something else in charge of the flop, and then so on and so forth. Now, one thing to keep in mind is that this combo, 2-card combo, is based on known cards. So I would like to add a feature that would basically try to predict what other players have, not just what you have. And this is where we will have to get some complicated stuff later on. And this is why I love my blocks. So these blocks will need to probably, if we do them as sub VIs, it would further simplify how this works. I will get